Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. So for 12 is environmental management. We have it broken down into 4 sections again. Sustainable energy supplies is first for 12.1. Now, the primary sources of energy that we have: fossil fuels, renewable, and nuclear power. Secondary sources then is when we're using that power through another source like electricity and hydrogen using fuel cells as well. So they're processed. When we look at those components then, what are things that are driving energy sources? Economic development, population growth, the global population rising very fast, and also development level increasing very rapidly. Looking at the mix then between different countries, we see the USA and Germany, Norway, China, India here. And we just have a look at the general changes of mix and percentages here. So USA for 80% fossil fuels, and 8% nuclear, 12% renewables. Kind of similar mix then with China as well, very similar with fossil fuels, nuclear and renewables being about 11, and China then, India with 75, 3, and 22. So there's kind of similarities there. Obviously, a bit of a difference between nuclear and fossil fuel capacity with India, and renewable energy percentage increasing drastically. Germany and Norway then show a much less reliance then on fossil fuels. This would be because they're less industrial and need a lot less power overall, and can have a higher percentage of renewables. Germany with 25% and Norway with 65%. We see then with Norway having zero nuclear power and a mix only between fossil fuels and renewables. So not all countries have access to nuclear power, and not all countries are looking for access to nuclear power either. It just depends again on your demands versus what your natural resources are and your capability to develop that as well. Okay, so just in general, a little recap here from things from GCSE, and that we're just looking at how energy is produced like by these types of sources. So the heat source in this case is coal, a classic way. We looked at the industrializing countries, for example. So many of those rely so heavily on coal production. So coal then is fed into a furnace. Inside the furnace, then it's going to burn, releasing heat. That heat is going to generate steam, and that steam is going to create pressure. The pressure the steam creates then is going to travel through, and that pressure spins turbines. Those turbines then continue to spin, and they generate, and they spin the generator, creating electrical energy from this kinetic motion. So that electricity then is sent out to transmission lines, transformers, to make sure that it's going at the right voltage, and sent out from this area into places like homes. The rest of the waste then, water can be recycled or can be sent back out into the river, and then we can release the gases outwards as well. So the steam can be cooled and released too. So that's the general process there, and we've been doing this since the Industrial Revolution, and we're using coal power and steam power, for example, and this all goes into electrical grids. Those grids then are going to be made up of different electrical sources. The grids then are going to be hooked up then into the homes and the local areas, and this means that huge areas can be connected to one singular grid of electricity. So this means that we're just trying to power these huge grids and ensure that there's enough for the demand that's within it. Now, coal is a carbon-based fossil fuel. It's buried over 300 million years, and it means that it's going to be compacted and compressed. It's very efficient. It can be dug straight out of the ground and burned. It releases huge amounts of heat for its weight, which makes it incredibly efficient then for energy production and industry, especially if we're thinking about, just general profits. The negatives is the pollution, general air pollution, the greenhouse gases, the addition then to the greenhouse gas effect that it has. So that is some of the downsides. Also, it's the environmental degradation of the actual removal of the coal as well. It can be very, very problematic. Oil has almost the exact same history there. It's buried. It's often buried with trapped life forms in water. So carbon-based life forms then again trapped, compacted, and compressed over time. So under pressure then becomes oil, and this can be then extracted from the ground up as well. Now, some of that needs to be refined into different methods, but we found that its primary use then is for transport. It's used a lot for that, where we're able to fill up the oil tank, and we're able to then let small amounts through in order to fuel combustion engines. This has created then a lot of this has made it one of the most important exports in the entire world, and one of the most universally used types of fossil fuels. So this actually needs a lot of transportation. Extraction can be very dangerous, and although it doesn't often go wrong, like it's not every single day, but when it does, it usually leads to huge environmental catastrophes in the area with oil spills. So we can see there the general producers versus the consumers of oil. USA, China, India, Japan coming in there as a high amount of barrels per day, and USA, Saudi, Russia, and China then producing then the largest amount per day as well. We have gas trapped above areas where oil is formed, and this can become trapped and can be released. This can burn a lot cleaner and lead to less particles in the atmosphere and pollution. It's dangerous though, as it can be unstable, and if there's a reaction or an explosion, this will cause quite a large one, as the gas is usually interconnected and is transported through huge gas lines. The general idea then is that it's used in domestic purposes, for energy, for industry, and it can be and liquefied gas as well can be used as well for transport. So it's probably the most versatile then because of that. Fracking is a new way of extraction, looking into pumping in water and sand